Betelgeuse, a massive red giant star, is an astronomical wonder that, if placed in our solar system, would extend all the way to the orbit of Jupiter. This temperamental star, known for its volatility, is nearing the end of its life and is expected to detonate in a spectacular explosion. These bursts, among the most intense in the universe, emit an incredible amount of energy, surpassing even 1 billion suns. Are you ready for the moment when this cosmic event occurs? Betelgeuse, one of the closest red giant stars to Earth, has recently gone through a notable shrinkage that has raised both interest and concern across the globe. The shrinkage has sparked speculation among both scientists and the public about the potential outcomes of this event. Some astronomers suggest that Betelgeuse's unusual behavior could be a precursor to a supernova, a catastrophic explosion that happens when a star runs out of fuel and collapses under its gravity, releasing a massive burst of energy. This potential event has many researchers, and the general public, asking what the consequences for Earth might be if such an explosion occurs. Betelgeuse, also known as Alpha Orionis, is the brightest and largest star in the Orion constellation. It is easily identifiable in the night sky, and with ongoing observations from NASA's Hubble Space Telescope and other observatories, scientists have detected a remarkable event. Betelgeuse underwent a massive mass infusion in 2019. This type of behavior is extremely rare for a star of its size, and has intrigued astronomers all over the world. Although coronal mass ejections are common for our Sun, the scale and scope of what occurred with Betelgeuse offer new perspectives on the life cycles of stars, and how these massive celestial bodies evolve. The distance to Betelgeuse remains a topic of debate. Some estimates place it further away, while others suggest it could be as close as 724 light-years from Earth. Determining the exact distance of red giants, like Betelgeuse, is challenging due to their vast distances and unique characteristics. Betelgeuse is one of the most brilliant stars in the sky, radiating about 1,000 times more light than our Sun. However, this immense brightness comes at a steep price. The star consumes its nuclear fuel much faster, accelerating its inevitable demise. In the distant future, Betelgeuse will exhaust its fuel, leading to a collapse under its own gravity, potentially triggering a supernova, a colossal explosion that could form a neutron star or even a black hole. This scenario raises a critical question: does Betelgeuse pose a risk to Earth? If a cosmic explosion were to occur only a few light-years from us, the consequences could be catastrophic. The explosion of a supernova has the potential to release an amount of light comparable to an entire galaxy. Therefore, even if Betelgeuse is situated at a considerable distance, the effects of such an event could be far-reaching. While Earth has not witnessed a local supernova since the year 1604, the explosion of SN 1987A in the Large Magellanic Cloud, located 169,000 light-years away, provided a glimpse of the massive impacts of such events. However, this explosion did not pose an immediate threat to Earth. The idea of a danger zone around a cosmic explosion is an intriguing one, with potential life-altering consequences for Earth if one were to occur closer to our planet. That said, in the grand scheme of cosmic events, supernovae are comparatively minor when set against the destructive power of gamma-ray bursts, which are much stronger and represent another significant hazard. Supernovae can have disastrous effects, potentially obliterating the ozone layer of a planet, leaving its surface vulnerable to harmful radiation. A recent study highlighted the risks posed by the deaths of massive stars, emphasizing that when these stars explode, they release some of the brightest luminosities known in the universe. In fact, a single supernova explosion can outshine entire galaxies, raising questions about the potential consequences if Betelgeuse were to undergo such an event. If Betelgeuse were to explode, it would become the second brightest object in the sky, right after the Sun. Despite its distance, Betelgeuse would be visible during the day, shining brighter than the full moon. The sheer intensity of the blast would cast shadows even in the dead of night, creating an awe-inspiring, yet frightening spectacle. However, while the visible light from such an explosion is immense, it is only a small part of the total energy released. Alongside this light, high-energy radiation in the form of X-rays and gamma rays would be emitted, posing significant risks. One of the major threats posed by this radiation is its ability to strip away the oxygen in our ozone layer. This layer is crucial for protecting life on Earth from the sun's harmful rays, and without it, life on the planet would be exposed to intense ultraviolet radiation, potentially triggering mass extinction events. Following the initial explosion, the long-term risks would intensify as high-energy particles, propelled at near-light speeds, infiltrate the solar system. These cosmic rays can damage the ozone layer, exposing Earth's surface to even more harmful radiation, which could persist for centuries. Scientists have found evidence that such cosmic events have affected Earth in the past. For example, elevated levels of iron-60, a radioactive isotope produced in supernovae, have been detected in seafloor silt and lunar regolith. This suggests that our planet may have been impacted by cosmic explosion debris in the relatively recent past, perhaps within the last few million years. Currently, there are no immediate threats from nearby supernova candidates based on our understanding of gamma rays and cosmic rays. However, new research has unveiled additional risks related to certain types of supernovae. These explosions can release long-range radiation, including lethal X-rays, which pose a much greater threat to planets like Earth. This happens when a star, nearing the end of its life, is surrounded by a massive disk of material. When the explosion occurs, the shock wave heats up this disk, producing high-energy radiation that can travel vast distances, potentially depleting a planet's ozone layer. The most luminous X-ray supernovae can deplete a planet's ozone by up to 50%, creating conditions that might trigger extinction events within a 150 light-year radius. Fortunately, no such X-ray supernovae have been identified near Earth yet. However, this research has provided valuable insights into the cosmic habitable zone, the region within galaxies where conditions might be suitable for life. The outer edges of a galaxy lack sufficient star formation to produce the necessary elements for rocky planet formation. On the other hand, the inner regions, where stars form and die more quickly, pose their own risks, as continuous supernovae in these areas increase the potential dangers for any life that might exist there. According to recent findings, the inner boundary of the cosmic habitable zone is likely located farther from the galactic center than previously thought. This reshapes our understanding of where life might be most likely to exist. As for Betelgeuse, if it were to explode, the event would be visible from Earth for months. Despite the distance, the explosion's light would make the star appear as a brilliant point in the sky, visible even in the daytime. Its brightness would rival that of the moon, and it would cast shadows even during the night. The cosmic display would be both awe-inspiring and terrifying, offering a vivid illustration of the raw power of such cosmic events. As Betelgeuse's explosion would remain visible for several months, scientists would continue to study the event, gaining valuable insights into the life cycles of massive stars and the processes that lead to their dramatic deaths. These explosions play a critical role in the creation of heavy elements like gold, silver, and uranium, formed in the extreme heat and pressure of the blast. This process, known as nucleosynthesis, enriches the interstellar medium with the building blocks of life, which can later become part of new planetary systems. Betelgeuse's death will contribute to the ongoing cycle of stellar evolution, enriching the surrounding space with material that will help form new stars and planets. Over billions of years, some of this material could even become part of systems capable of supporting life. Just as the elements in our solar system originated from the explosion of previous stars, this continuous process of creation and destruction ensures that the universe remains dynamic. While we may not witness Betelgeuse's final moments, future civilizations on Earth or elsewhere in the cosmos will likely continue to study its legacy. Betelgeuse's eventual supernova will mark the end of one chapter in the universe's story and the beginning of another. As the universe continues to evolve, Betelgeuse's explosion will serve as a powerful reminder of the forces that shape the cosmos. It will leave a lasting impact on our understanding of the universe and our place within it, while also offering a glimpse into the ongoing cycle of life, death, and rebirth that defines the stars. Though the explosion will not pose a direct threat to Earth, its magnificence and far-reaching consequences will undoubtedly captivate humanity's imagination and deepen our understanding of the universe. As we continue to explore the mysteries of stellar evolution and the potential for life elsewhere, Betelgeuse's fate will remain a significant chapter in the ongoing story of cosmic discovery.